This presentation will discuss the process of formulating a hypothesis. After clearly stating the research problem and examining related literature, the researcher is ready to state a hypothesis. The hypothesis represents the researcher's expectations about the relationship between the variables of the problem. A research investigation begins with a question, but questions cannot be tested directly. It is the proposed relationship between the variables that is tested. The hypothesis represents an educated guess about what will happen in an experiment. A research hypothesis is a testable statement derived from the research question. The null hypothesis states that there is no relationship between the two variables being studied. In other words, one variable does not affect the other. It is a negation of what the experimenter actually expects or predicts. A null hypothesis is used because it enables researchers to compare their findings with chance expectations through statistical tests. It states that the results are due to chance and are not significant in terms of supporting the idea being investigated. The alternative hypothesis states that there is a relationship between the two variables being studied. In other words, one variable has an effect on the other. It states that the results are not due to chance and that they are significant in terms of supporting the theory being investigated. Hypotheses may be either directional or non-directional. A directional hypothesis specifies the nature of the relationship or difference that is being predicted, such as that a specific group or condition will be higher or lower or have more or less of something, or it predicts the specific direction that a correlation will take. A non-directional hypothesis, on the other hand, states that a relationship or difference exists, but without specifying the nature of the expected finding. An example of a directional hypothesis would be, deaf children whose parents are deaf will acquire language faster than deaf children whose parents are not deaf. This specifies the direction of the condition. One group is faster than the other. An example of a non-directional hypothesis would be, male and female supervisors will differ significantly in their use of threats as a compliance-gaining strategy. This indicates only that there is a difference between the groups. Let's look at some examples of the progression of the formulation of a hypothesis. Suppose our research question is, do students work better on Monday morning than they do on a Friday afternoon? We decide to study this by giving the same group of students a lesson on a Monday morning and on a Friday afternoon. We then measure their immediate recall on the material covered in each session. So our hypothesis could be, students will recall significantly more information on a Monday morning than on a Friday afternoon. For the research question, does eating breakfast affect student performance? A hypothesis could be, students who eat breakfast will perform better on a math exam than students who do not eat breakfast. For the research question, does using a cell phone while driving affect driver performance? A hypothesis could be, motorists who talk on the phone while driving will be more likely to make errors on a driving course than those who do not talk on the phone. It is not possible to test a hypothesis directly. Instead, you must turn the hypothesis into a null hypothesis, as described previously. The null hypothesis can be created from the hypothesis by adding the words no or not to the statement. The null hypothesis is, therefore, the opposite of the experimental hypothesis in that it states that there will be no change in the variable under study. An analogy for this is the criminal trial. Imagine you are the prosecutor. You believe and want to show evidence that the defendant is guilty. That is your alternative hypothesis. but you must assume that the defendant is innocent until proven guilty. So the null hypothesis is that the defendant is not guilty. Let's look at some examples for creating the null hypothesis. From our previous example, where our research question was, do students work better on Monday morning than they do on a Friday afternoon? We developed the alternative hypothesis. Students will recall significantly more information on a Monday morning than on a Friday afternoon. So in this case, our null hypothesis would be, there will be no significant difference in the amount of information recalled on a Monday morning as compared to a Friday afternoon. The null hypothesis assumes that any difference in the sample will be due to chance or confounding factors. In our second example, our research question was, does eating breakfast affect student performance? And our hypothesis was, students who eat breakfast will perform better on a math exam than students who do not eat breakfast. Therefore, the null hypothesis would be, there will be no significant difference in the performance of students who eat breakfast as compared to students who do not eat breakfast. Finally, in our third example, the research question was, does using a cell phone while driving affect driver performance? And our hypothesis was, motorists who talk on the phone while driving will be more likely to make errors on a driving course than those who do not talk on the phone. And so, our null hypothesis would be, there will be no significant difference in the number of errors on a driving course for individuals talking on a phone as compared to individuals not talking on a phone. All statistical testing is done on the null hypothesis, never the hypothesis. The result of a statistical test will enable you to either reject the null hypothesis or fail to reject the null hypothesis. We never use the words accept the null hypothesis. The null hypothesis is supported if the results are statistically non-significant. The null hypothesis is never proven, at least not by a single study. There is an impossibility of proving a negative. The null hypothesis is rejected in favor of the experimental or alternative hypothesis if the results are statistically significant. In the next steps of the research process, you will proceed to testing the hypothesis. You will consider how to collect the data on the variables you have defined in your research question and your hypothesis about their relationship. Essentially, for this stage, you will be completing the sentence, a way I can test this hypothesis is, after collecting the data, you will analyze it to determine whether or not evidence supports your hypothesis. In this step, you will complete the sentence, I'll know my hypothesis is supported if. In this way, each of the subsequent steps develops logically from the formulation of a clear and testable hypothesis. I hope this presentation has provided some helpful information and clarified the process of formulating a hypothesis.